I'm Charlie Carter, President of AISC, and thank you all for joining us today for a steel table talk with 7 distinguished leaders from the design community and steel construction industry. Earlier this year, AISC awarded each of our participants today with a special honor, which I'll describe momentarily. I would have loved to share the stage with each of you at the conference as planned, but I'm honored to moderate this panel of all of you who are making a difference for everyone involved in the design and construction of steel buildings and bridges. First, it's my privilege to welcome our Lifetime Achievement Award winners who are here with us, and there are 4. I'll name them all: Carol Drucker, Dan Fisher, Ronnie Medlock, and John Yedlowski. And if each of you would just take a moment and introduce yourself. So we can start with Carol on that.
Hello, everyone. I'm Carol Drucker, principal at Drucker Zidell Structural Engineers in Chicago.
Okay, thanks, Carol. And Dan, you're next.
I'm Dan Fisher, Sr. I was one of the founding partners of Girder Slab Technologies. I'm now semi-retired. I should say fully retired. They call me the ambassador, the new business ambassador for Girder Slab. Thank you.
Well, thank you, Mr. Next up, Ronnie Medlock, please.
Hi, I'm Ronnie Medlock, Vice President of Technical Services at High Steel Structures in Lancaster, Pennsylvania.
Okay, thank you, Ronnie. And last up, John Yedlowski.
Howdy, John Yedlowski, HDR Engineering out of Pittsburgh, Pennsylvania. I'm a senior bridge engineer.
Okay, thank you all. Next, you can see there are 3 more panelists, and I'm further privileged to welcome our 2 Special Achievement Award recipients, Ron Clemencik, who is being recognized for work on the Speed Core system, and Rex Lewis, who is being recognized for developing what is now known as the Rex I. Lewis Scholarship given by the Education Foundation. And through efforts that Rex led with a group of his friends. Ron and Rex, would you please introduce yourselves in that order?
Sure, thanks, Charlie. Ron Clemencik here, Magnus and Clemencik Associates in Seattle, Washington, and Chicago, Illinois. Structural engineer by day and all sorts of other things by night.
Hi, I'm Rex Lewis. I'm the president of Komo Steel, and as long as we're listing our other occupations, I'm the stable boy at night for my wife.
Nice.
I've seen his stable, he doesn't lie. Okay, and finally, I'm pleased to welcome the 2020 T.R. Higgins Lectureship Award recipient, Bo Dowswell. Bo, please tell us a little bit about yourself.
Yeah, thanks, Charlie. Bo Dowswell. I'm in Birmingham, Alabama, and I'm a consultant, structural engineering consultant, primarily for structural steel. And I guess I'll carry on the part about talking about what we do at night. I'm actually an adjunct professor at the University of Alabama at Birmingham at night, where I do steel-related research and teach connection design.
Thank you, Bo. Now, there's a few of you who have a little bit of an academic connection, and I'll warn you that there's a session on Wednesday at about this time for the educators, and if you go down that path enough, we'll invite you to join that one too. Okay, well, thank you all, and let me again share my congratulations with each of you. You make for a very impressive virtual stage, and I'm glad we have this opportunity to celebrate you and talk with you today. And I especially appreciate that I get the honor to moderate. If you're part of the audience, I encourage you to submit questions in the comments section. We will be answering audience questions later in the roundtable, and I've got a few to get the conversation started. And start with what should be a fairly easy one. I'm sure everyone has one. What is your absolute favorite steel structure? And we can see each other on the panel, so we can avoid talking over each other. If somebody wants to get in first, puts their hand up. There's John.
Okay, so the Liberty Bridge in Pittsburgh, Pennsylvania. I'd mentioned that in my interview. It's a spectacular steel truss, towers over the Monongahela River. Recently, the contractor tried to burn it down, but we were able to fix it, the part that he burned, and replace the deck and do a whole bunch of other things that were being done at the same time. It's a magnificent structure. Google it if you get a chance. Liberty Bridge.
How old is that bridge, John?
1938 is what I think I remember. So quickly doing the math, we're pushing almost 80 years.
Yeah, wow. Amazing. There you go, Dan. Are you next?
Well, I guess so. I just circle back to what I read years ago about Frank Lloyd Wright, the architect. And my best job is going to be the next one we get. We've got 250 of them now, and a lot of people didn't think we'd ever get one built. So honestly, we just go from job to job, and the next one that comes along will be the most important one to me. So I like to answer it that way.
I could take it,
Next.
Charlie.
Go ahead, Carol.
I do like that answer, and I do appreciate that answer. Maybe I should answer it the same way, but deep in my heart, I love Willis Tower or Sears Tower if you're old school. Our office is across the street, and I just think that's a wonderful icon for the city of Chicago. I love that structure, and I love the history behind it. And after we did our AISC tour of it a few years ago with a group of Chicago structural engineers, it's actually now a sentimental building too. So I really like that structure.
It's amazing how much square footage they added around the base of it. And then they put us in an elevator and took us to the top, and we got a nice view.
Yes.
The higher we went, the colder it got.
And not to mention the new food court is very nice too. I like the new food court.
No waiting in line right now, I bet.
No waiting in line.
I'll talk about.
Go ahead, Rex. You're next.
The one I like is actually no longer there. I think everybody probably knows it by name, Mile High Stadium. It's been replaced. But what was really unique about that not many people understood was the entire east stands was mobile. And it was quite an engineering feat when it was designed. It was designed to ride on a water bed, and they could move it to the baseball configuration, or they could contract it into the football configuration. And it was really quite an engineering marvel at the time. Assume the stands could, I think the stadium held 75,000, so it probably holds stands that hold 30,000 people. And yet it was mobile. And so it was an interesting structure.
Ronnie, I think you were vying with Rex there. He beat you by just a syllable. So we'll go to you next.
Sure. Yeah, my favorite structure is a more recent project, the Mario Komo Bridge, which is the replacement for the Tappan Zee. It's a 3-mile long bridge. In some respects, it's not as extraordinary as some structures, in terms of its beauty or striking presence, but, it's a girder bridge. The main span is a cable stay, but what impresses me are the approaches, which are 3 miles long, and girders. But the thing about that project was the remarkable excellence in the execution. We did half of the approaches, 780 girders, 2,800 cross frames, and these cross frames are 18 by 9 feet, giant. And the thing that was amazing is how well that project went. The steel being delivered on schedule. The contractor's amazing means of doing assembly off-site, floating giant sections down river, lifting on the bridge. Lots of really extraordinary work done on that bridge, and it was our company, High Steel's largest project ever. For its excellence, my favorite structure.
It's nice, and that's almost the next one for you. It was one of the last ones for you. Okay, Bo and Ron, anything you want to share on your thoughts?
Well, I'll go next. I'm going to go a little bit off the wall here, being that I'm mostly involved with industrial structures. I guess I better select an industrial structure, but I'm going to go with a group of structures, Sloss Furnaces, which is an old iron making facility in Birmingham that is now a museum that you can go through, and I could actually see it out of my condo window from downtown. And what it is it's a group of I believe it's 2 furnaces, and you can actually see the steel stacks from miles and miles away. But they've also got the casting sheds that you can walk through, and all of the other buildings, and it's kind of a almost an iron colored paint on it. So it's just a beautiful structure to me. And I know a lot of people in Birmingham probably think it's an eyesore, but it pretty much tells the history of Birmingham. So it's a really, really nice place to visit if you're in town.
And what was it
To
originally?
visit it.
What was it, Bo, originally?
It's Sloss Furnaces, and that's what it still is. It's an old iron making facility in Birmingham, downtown Birmingham. And essentially what they did is they were several decades ago, they were talking about tearing it down, and they had some people that got together and decided to raise funds for it, and they turned it into a museum where you can go through, and they have a really nice museum that shows videos and things like that. But the main attraction to me is being able to walk up on, and if you're sneaky enough, you can jump the little safety gate and go all the way to the top of one of the structures. And it's kind of a little bit rusty, so you have to be careful. But once you get up there, you can see the whole an overall view of how they made the iron, the pig iron back then in Birmingham.
Sounds fun. Ron?
Yeah, probably my favorite steel structure for its beauty is the Golden Gate Bridge. It became even more beautiful to me when I learned it was designed by a Purdue engineer. Go Boilers. Probably the favorite project I've personally worked on is the Amazon Spheres, which if you haven't looked at that, it's worthy of a Google visit. The Amazon Spheres, and the interesting factoid about the Amazon Spheres is that despite how complicated they appear, there's only 12 drawings that describe the entirety of the structure, which in this day and age, that's a thing of beauty in and of itself. If you can design and describe a very, very seemingly complicated structure in 12 drawings, something magical has happened. And then I'm with Dan. The next project, the best project is always the next project.
Yeah.
Dan, I think you won the question. You got a lot of agreement with.
Definitely.
That's all about more jobs for the steel industry. So it's the next one that's important to me and to Ron. That's it.
From your lips to God's ear.
Yeah.
Well, a little more philosophical here. This is a group of people that's very accomplished, and I wonder, you've benefited from some advice over your years. What's the best piece of advice that you received?
I'll jump into that one. Honestly, I don't know that anybody really gave it to me, but well, I guess I could say, my dad would talk about his time in the Pacific War in the Navy. And when he got out, one time he opened up to me on the way from an Iron League meeting, and all he wanted to do was live to be 50 years old. And that's what he would pray to God for when he was in those foxholes. So it really instilled in me a knowledge of how life is really short. And, you know, when we have an opportunity to try something new, you know, to step off the cliff, so to speak, if the timing is right, you know, for the family, it can be worth it. And that was one of the things that I decided to do back in my early 50s. And it worked out very well, and I'm glad that I did it. So that was very important to me. Just realize, you know, all of a sudden I'll be 72 years old this year. And the last 20 years were really a lot of fun. So that's my perspective on it, Charlie.
Thanks, Stan. Who else?
It's a tough question, but fortunately I had Dan's time to think about it a bit. I don't know if it's the best advice, Charlie, but certainly a key thing is to do what you can to help others. Yeah. You know, in terms of our engineering work, we're all a big community, a big team. And we can get focused in on our task, but we shouldn't forget that there are a lot of other people out there who can learn from the things that we know and could benefit from our help, including people who are outside our organization and also inside. And, you know, not just peers, but from the shop floor right up through the senior management of an organization, respect others and just see what you can do to help them. If you do that, you'll help them and you'll also learn along the way.
I'll share one advice. I don't know if it's exactly advice, but more of a life observation that John Magnuson shared with me years ago when I first started with the company. And he said to me that for the rest of your life, you're going to struggle with three things and balancing those three things. And that's your family, your career, and your health. And you can only do two well at any given time.
It's interesting.
Well, that's sad.
I'm just saying.
Some of us can do all three.
I don't know. I guess I've found his. Again, I wouldn't say necessarily advice, more just life observation. For me, it's held very true.
You just have to take off sleep. Sleep has to go.
Yeah, well, that somehow plays to your health, right? So.
Yeah. My brother gave me some good advice. I think, I don't know if he's a web developer, and he actually gave me some advice in website design, but I think it applies to structural engineering too. He said that to build a very good website, an excellent website, you have to build a terrible one first. And the same principle applies to structural engineering. Like, don't be afraid of failure. If you don't know the right path, just start on a path, and then the right one will eventually present itself. I think that's actually pretty good advice.
I agree with that very much. You know, the way we came about with our idea was just trial and error. We really just came up with the geometry solution for our unique beam. And once the geometry worked, then we just tested the beams. We tested 7 beams before we found one that would give us an appropriate span. So it was really just, you know, a lot of failure. And I'll never forget one time when my dad was still alive, we had a little assembly put together in the column shop in the back of my steel fabricating shop. And we were quite proud of it, myself and our 2 partners. We had actually, the first D-beam we invented or came up with, I had the idea, along with my engineering partner. We took a wide flange beam and we cut it. We ripped it down the web, and then we found an old I-beam section that I had in the shop because I used to do petrochemical work. So I said, well, what if we took that I-beam and ripped it down the web and full pen welded the 2 things together? So when I put that sketch in the shop for my mechanics on a Monday morning, they looked at me like I was crazy. But we welded together an I-beam and a wide flange beam. We brought in some plank, put an assembly together, grouted it together, put a load on it. And then my dad came over on a Sunday morning and he was standing in the upper part of the shop looking at our assembly, kind of half with a grin on his face. And, you know, we had taken the load off it and we actually saw some composite connection come back because we had superimposed a load on it, I think on Friday or Saturday, with just some truck jacks. We just jacked a load into it. But anyway, I walked up to Dad and I said, what do you think? And he said, when the hell are you going to get this out of the way? I got columns I got to fabricate and deliver by next week. So, you know, it was that type of thing. It was all failure first, you know, until we found something that worked. Because that just gave us the geometry. Then we had to go to the lab and actually test I think we had 8 or 9 beams and we finally, you know, found beam number 7. That gave us some capacity, but it was 6 failures before that. And you guys know what it's like when you destroy something in the lab. You know, you got to clean it up, reassemble it, you know, put everything back together again. So quite a bit of effort, but a lot of fun, a lot of fun.
Yeah, Carol, I agree with yours too, that but I think that not only it applies to beams and websites and structural engineering, but also just to ideas. So you really can't be discouraged if you come up with an idea and it doesn't work. You know, your first 9 ideas may not work, and then you finally hit one on the head and crunch through the numbers, and you've got a good idea, and you're one ahead of most other people at that point.
Yeah.
Have confidence in yourself without being cocky.
Right.
Doing a project, bridge got hit. We've got this thing up on false work. We got it on rollers. We're going to move it back into position. My boss looked at me on Saturday morning and he said, you know, I have faith in you, but if this doesn't go well, don't come in on Monday. It went well. So have faith in yourself, bring others along with you.
Mm-hmm. Yeah, I'll reinforce that thought again. When we got through our technical part of it, and then we sat down and figured out how are we going to create a business plan. The business plan, you know, was hammered out to make our intellectual property available to any structural engineer who wanted to use it, and make it as free and available to everybody. And of course, my mantra was always to, you know, convince or make it available to the steel fabricators, because it became more steel jobs. Our effort was to convert or offer a substitute to the architect and structural engineer for something that would benefit the owner compared to other more expensive systems, and additionally to allow any steel fabricator to manufacture the unique beam in their own shop. So this would add more tonnage and more labor hours, which has always been very important to me as a steel fabricator. The more work you can provide by not invading, but participating in the multi-story residential market, which has traditionally been another type of system, and can, you know, convert those jobs to structural steel. That's a lot of tonnage for our steel fabricators, and that's what has always made me very proud. That the steel guys, you know, they look at it now and they say, wow, you know, this job would have been something else, and now it's structural steel and bracing and all that good stuff. So they love it. And I'll leave it at that, Charlie. Thank you.
Anyone else run in with some advice?
This is Rex. I had, when I was a young guy, a little bit of advice given to me that's stuck, and that was regarding work ethic. It was, would you like to be successful? I said, sure. He says, I can put you in the 10% of the top of the class right now. I said, how do you do that? He says, start early, finish late, and work harder than anybody else. You're already in the 10%.
Yep.
Good advice.
Yeah, I used to have a little 3x5 index card at college, and it was that quote from Calvin Coolidge, the president, that was about persistence and how persistence, many people are born, you know, with high intellectual abilities and a lot of natural talent. And that certainly wasn't me, but I was a persistent guy. I still am. And I think that was something that was very beneficial. And if you just keep sticking to it, like you said, Rex, I was the last one to turn off the lights in the shop at night, you know, and the last one to go through the shop and make sure the welding machines were turned off and the cranes were turned off and so forth. So very much relate to that. Thank you.
Let me take us a little different direction here. I'll just throw it open for panelists. What would you ask of your fellow panelists?
Well, I just say to Ron, keep working on that speed core thing. That's fantastic. That I think is just going to mean a whole lot to us. I had all kinds of problems with bracing, and anything we can do to get that speed core system in the quiver of the architects and engineers, I think is going to be fantastic. Thank you.
Yeah, thank you. Number 2 is under construction, and I'm sending the drawings out for number 3 today.
Great. I'd love to see a copy of them. I really would. You know, just a couple sections through there. I'd love to get more familiar with that. Yeah.
Yeah, I want to sing harmony there on steel core. It's really impressive. My question to you, Ron, or others is, it's been revolutionary in the steel industry. The speed of erection has been a significant change. But my observation from afar is that the other trades couldn't quite keep up, or they weren't anticipating the rate of the core and the steel frame going up, and so they weren't ready for the amount of speed that the steel core provided. So my question is, tell us about what the rest of the industry, the construction industry, or the design can learn from this, and how can we change it from being a revolutionary steel erection process to shortening the overall construction schedule.
I might take a whack at part of that at least. And there's a lot of work going on in this area in various ways, but the modularity and prefabrication of componentry has long been an aspiration for all sorts of people in the industry, but it's starting to really get some traction in different ways. And it's not the prefabrication, what's called volumetric prefabrication, where you're building boxcar size things. Instead, it's prefabrication of pieces that can be more easily shipped. And then taking as much as the field work out of the field and putting it in the shop, and then making the assembly in the field simpler and faster. And there's a lot of advancement going on there. I tell you, the Australians are way ahead of us on this. And so if we want to catch up, we need to go to Australia and watch what they're doing, because they're kicking our ass right now. So.
I will let my friends at the Australian Steel Institute know that I need to take some notes.
Yes.
Why don't you invite them, Charlie, to the next trade show that we have and have them lecture. That'd be an interesting learning credit thing, you know.
You do
So
that.
Dan, spinning off of your girder slab idea, the Australians have taken that one step further and introduced pre-stressing tendons to the webs of the beams to get the
Wow.
spans longer.
Yeah.
And it's very similar. They've modularized the floor panels and pre-stressed the beams. And so they can get much longer spans in the same depth and prefabricate panels of kind of living units, if you will. It's very intriguing.
That'll be for the next generation, Ron.
Yeah.
Yeah.
I'm worried about my golf game now.
Good for you. Yeah. We are, as some of you know, I think AISC is spearheading an effort to develop something that we're calling Speed Floor, which is intended to be the complement to Speed Core. And again, the goal is to go fast through prefabrication and modularization. And we're working on it diligently as we speak. We don't have the final outcome yet, but it's in the works.
Very excited about that.
Mhm.
Anyone else want to ask a question of another panelist?
I've got a philosophical question, not assembly and fabrication, but back in the day, molding and riveting was replaced by welding. What's coming? What's next? Is there anything? Medlock?
Ooh, he called you
Yeah,
out
it's a
by
good
name.
question.
I can do that.
Yeah, you know, it's a good question, John. You just never know, do you? Who would have thought when they were riveting so much that that would be passe and really just dead technology, really. Welding, though, is so extraordinary and so effective. Can I say nothing will beat it? Of course not. But what you can do with it offers so much flexibility. Perhaps adhesives, you know, a combination of adhesives with other types of connection. I don't see adhesives taking the place of welding, but maybe complementing it. That might be one of the next best material or joining technologies out there. I think there's a lot of potential for it. What do you think about that? Yeah, go ahead.
Yeah, it's interesting you mentioned the adhesives. We're looking at doing some testing with cross-laminated timber and the structural steel frame. And we get to the part where we need to grout the floor system to the steel. So we're looking now at adhesives that might be able to take the place of cementatious grout. But of course, all these are just ideas and they need to be tested to at least see if there is any light at the end of the tunnel there. But that's something that, you know, we're looking at it, and I think there might be some possibility. We don't want any staining on the cross-laminated timber, you know, that sort of thing. But so maybe the adhesives do have a place. We'll certainly share that with Charlie if anything comes about.
I'll take a philosophical question. So we're looking at a 360-degree turn. As you might know, I got a little gray hair on top of my head, so I wasn't around for riveting, but the guys I worked with when I was a young guy certainly were. We're a bolt shop, and we've actually, I don't know if it was for humor or for test, but made substantial structures without a weld in them. Everything's bolted. The base plates are bolted. Every connection's bolted in the shop, bolted in the field. And we find it, I don't know if humorous is the right term, but the design communities become very comfortable with welding. But the state of the art of technologies, 3D modeling, and being able, what we call intelligent models, where you take the data out of the model that runs your CNC equipment. And of course, your CNC equipment puts holes in it at an amazing rate, whether it's a connection or a primary beam or a secondary beam. We can send that data on a wireless network down to a CNC machine, and boom, we're off and running, as opposed to a welded connection. So we're a bolt shop, we bolt everything. But we look at it as a 360-degree turn with a little bit of humor, because the design construction community has come comfortable with welding technologies, and we have some comfort that the welding will maybe catch up or get close to the technology of bolted connections, meaning robots and welding robotics may get to where they can be, in our humble opinion, competitive with a bolted connection, or use the digital information out of the model to accomplish that. So, but the humor part of it is, we were riveting structures 100 years ago, and now people think you have to weld them. We see the difference between a high strength bolt and a rivet as the strength of the bolt, and that's about all.
Rex, let me ask you this question, Rex. Over the past 40 years, before the CNC equipment and so forth, how much more productivity do you think the average shop has gotten now that everybody's got the, the saws and the drill lines and the coping machines? And I mean, I remember, I got out of the steel fabricating business 22, 23 years ago. And I used to think in terms of a pretty clean job would run through the shop without pain at like eight man hours a ton. And, I'm just fascinated by the increase in productivity that must be happening to the average shop with all this equipment. I mean, I sometimes wonder, but I feel good about what I'm doing in a small way, trying to increase more jobs for the industry. But how do you keep all that equipment busy, especially when all your competitors have the same equipment?
Well, we have 3 beam lines. One's a punch line, one's a drill line, and one is a robotic plasma machine, all capable of running beams. So we can, I'll hit your coping question first of all, and talking with all these structural engineers, we almost design away from any kind of coping. We use tabs, and we buy a proprietary angle that allows us to use extended shear tabs, which, I'm going to play engineer for a second here. It adds a little eccentricity, but it does away with copes. So unless we have some tremendous loads on some primary members, we aren't going to cope them. We're going to take the connection away from the girder beam and just use a straight beam and drop it in. So there's one of the labor savings that we're doing with a bolted connection. I'm reluctant to answer your question in general terms, but I know there's some people right now. Let's say I'll try to avoid the name, but there's a huge distributor right now that's building all over the country, 1 million, 2 million square foot facilities. Those are selling for about 4 man hours a ton.
Wow. 4 man hours a ton.
Yeah.
I think I made.
Thank you.
No, that's yeah. And all this, Charlie, leads to we need to increase market share. I mean, it's just so much capacity is in the market. That's good news. But
let me share one other thing as long as we have a platform here. I think the real revolution is producing steel. When I was in, I think we were at 13 man hours a ton for a steel mill to produce a piece of wide flange beam, and now they're at less than 1/2 a man hour per ton to produce a wide flange beam. So that'll give you a view of the state of the art of producing steel in this country.
Yeah, I remember going to Bethlehem Steel Company when I was a kid, and that's about where they were. And now getting back to the plant that's still making pig iron, Bethlehem is what, a casino? I think they made a casino out of Bethlehem Steel Company.
And
They're probably making more money.
The other bit of revolution I think we're already seeing it on the fringe, is additive manufacturing. Additive is probably not ever going to make a wide flange as well as you can pop it out of a mill. But on the other hand, it gives you the flexibility to do a lot of intricate things. I think what we'll see is that in connections and smaller parts, just being able to dial in exactly what you want will provide the engineer with the flexibility to make some extraordinary changes to their design. Besides that, talk about CNC. You know, you've dreamt it up. You put the program in the machine. It takes it a while to make, but you can just let the machine make it and deliver it. So, you know, additive is not going to replace everything. But like bolting does with welding in terms of its, you know, how they complement each other, and adhesive as well, I think it'll just be one more tool in our toolbox. And if we're smart, we'll learn how to take advantage of that in combination with our other joining methods.
Rex, I'll jump in here, and the first thing I'll say is that you mentioned your gray hair, but I'll say that is better than no hair. So other than that, I am hearing a good bit of information coming out on where people are starting to use the steel castings for the connections.
Mm-hmm.
So I'm wondering if that's kind of going to be a thing of the future as it gets more where you can say if you have a couple of hundred of the same connections, you can get a custom cast or something like that in the future. I'm sure you can do it now, but may not be cost efficient right now. But I'm wondering if everybody is starting to see more of that.
I haven't seen any of it yet, but I certainly agree that there's a place for it.
Yeah, we haven't seen it either, but I agree too. I think castings have got a lot of potential, especially for complex nodes. Especially as you were saying, Bo, if you can repeat the same part multiple times on the same structure, it makes sense that you could take advantage of that.
Keep it simple.
It's a good moment here to shift to a few of the questions we have from the audience. And this might get back to Ronnie was talking about the Mario Komo, which was a project done under a Buy America requirement. And someone asked if anyone could explain and share the impact of Buy America for fabricators, and particularly that's more applicable in bridges than it is in buildings.
Mm-hmm. Well, I think it has a significant impact, Charlie. You know, the Buy America says, if you're not familiar with it, that if you're on a federal job, that the steel has to be manufactured, melted and manufactured. So it comes out of a mill, and it has to be fabricated in the United States. You know, I think on very large projects, there may otherwise be some intrusion from offshore. But for medium to smaller, you know, American fabricators and steel mills are very competitive. So on the smaller jobs, it may not have an impact, but on their larger scale, it certainly does. You know, I know that, you know, it's important to get a good value for the traveling public. And I think that that's something that is very well provided by the domestic manufacturers, both the mills and by the fabricators. So it certainly has an impact. Would, you know, mentioning the Mario Komo, would it have gone offshore had it been not for Buy America? That's hard to say. You know, a project of that size would certainly have been attractive. But the thing that made that job so effective was the design, and John can speak to that. You know, they optimized the girders for what could be readily shipped. You know, the 12-foot deep girder that we could put on a truck and send to the project site, very cost-effective fashion. You know, I think they did a good job producing an economical structure that lent to its speed. Without Buy America, what would have happened? Hard to say, but I certainly think we would have been competitive regardless.
Okay, thank you, Ronnie. Another question we got, and this can be for anyone who faced the challenge, who among us hasn't, but what's the most challenging structure or project that you've worked on?
The last one.
I think Dan may be able to attest to this, but it's research. You got something, you want to try to make it work, you get in front of a group of people, they don't necessarily understand, they're paying the bill. You've got to go back and rethink your delivery. How do you need to change up the message so that they understand it, get it built, get it through the lab, get the specs changed? I think some of the most challenging stuff is the research, trying to do something new.
Yeah, it was quite interesting in the beginning, and certainly I haven't done any traveling in the last 2 years, but it's a lot different when you walk into a structural engineer's office and you've got 15 million square feet under your belt, 250 jobs. But when you walked into an office and you had 1 job, 2 jobs, 3 jobs, was pretty challenging. So a lot of things have to be overcome, but it's just like we said, you've got to get the first job. You get the first job built, and then people look at it and say, well, why can't I do this 15 stories? And you say you can, it's just a function of the bracing. So you build one on top of the other, but it's a long road, and you have to have an engineering partner like I did to be able to answer the questions. I am not an engineer. I was a steel fabricator. So you can go out and talk to the fabricators, but you got to talk to the engineers, and the engineers have to understand what you're doing. And once you build on that, then it becomes accepted for the right job. And that's all it is. But yeah, there's a lot of work that went into it. And, it's different now, but in the beginning, these guys that have the new ideas, I always tell them, just keep getting more and more jobs built. That's all. Just keep getting them built. Thank you.
Yeah. I think every job has its own unique set of challenges. Some jobs, the challenges are bigger, some jobs they're smaller, but every job has their own issues and challenges. But that's what actually makes the job fun and rewarding at the end of it. Is the greater the challenge, the more rewarding it is at the end of the day.
Yeah.
Probably the most challenging thing I can think of recent. We worked on the design. It's not yet built, unfortunately, but we worked on the design of something that's called the Dubai Creek Tower. And imagine, if you will, everybody's probably familiar with the Burj Khalifa, which is currently the tallest building in the world, 828 meters. The Dubai Creek Tower put what was the equivalent height-wise of the Sears Tower on top of the Burj Khalifa. So it was essentially the equivalent of 3 Sears towers stacked on top of each other. It was crazy.
Yeah.
Anyway, we did the design. Well, we didn't. We worked with the designers. The design was actually done by Santiago Calatrava, but we worked with them on structural engineering aspects of it. And the things that we were forced to think about when you're dealing at those heights were things that you don't normally think about, like air density is different.
Yeah.
And the wind speed profile is very different, and the temperature is different. And how do you hoist things that high in the air? Anyway, maybe they'll build it someday, but it was fascinating nonetheless.
That's remarkable.
Dan touched on something that brings it to mind, the most challenging job. I don't know that I could pinpoint one, but I would say that the most challenging ones are the ones where we don't have that partnership. A company like ours, High Steel, has built tens of thousands of bridges for almost 100 years. We know quite a bit about it. And usually when we're working with a project team, a contractor, an engineer, and an owner, we're able to bring that to the table. And when things come up, we work through it. Probably 80 or 85% of our jobs go that way. But the other ones, for for some reason there's sort of a stone wall of no, the fabricator should not be at the table. We don't want to hear a discussion. We're going to tell you how things need to be. And we'll say, well, actually, this would be better. And there's no one listening, or they don't want to listen. That's unfortunate and frustrating. And those jobs become a big challenge. And Charlie, I think it points very much to your role and the role of AISC. And you guys do so well of educating the engineers. We reach out, educating the community how things should be, providing guidance, providing standards that engineers can follow, so we can build that trust and have a good relationship and have those successful jobs. That relationship is key. If we've got a good one, we'll have a good job. If we don't, it's a roll of the dice.
Charlie, I'll jump in and say I can't really think of a single structure, but just in general, when I was a detailer back in the mid '80s, I was lucky enough to work for, I didn't think it was luck at the time. I thought it was bad luck for a couple of detailing companies that they were well known for being able to do anything. So they took all this plate work and hip and valley roofs and things like that, curved chain conveyors. I can remember doing those. And Charlie McGee, the boss of McGee Detailing, would just put things on my desk and say, here you go, figure it out. And I was kind of lucky that he would give me plenty of time to do it and show me where I went wrong. So that's really helped me out in my career, is just being able to have that 3 years of experience working at McGee Detailing, doing all of these crazy structures that nobody else would really wanted to do. And the fact that I had a boss that allowed me the time to figure it all out. So just in general, hip and valley roofs are the toughest thing that I've done as a detailer.
Yeah, I'll just take a moment and give an old 25-year-old shout out to all the detailers that saved my butt on a lot of jobs.
Okay, let's sneak another question from the audience in here. Bo, you mentioned castings, and that made someone wonder about 3D printing. And has anybody seen 3D printing technology become a force in steel design and construction?
Probably coming, but I have
that.
not seen it.
Yeah. I was talking about the additive, and along those lines, Charlie, I think not really yet at our scale, but people are doing some massive things. So I'm with Carol. I think it's around the corner, not as a replacement, but as a complement to what we're doing.
Yeah, the example I've seen actually is a lot like welding, right? The continuous deposition of a weld in a tube form, and someone 3D printed welded a bridge over a span where the robot was actually climbing the structure that it was welding in place. I think there was stainless steel, to be fair, but
could do it. We could do it.
It's a pretty boutique solution.
I noticed that structure, I saw that had lots of folds. So they kept the structure thin, but they used a lot of folds to get the stiffness out of that very thin structure that they did, which I also thought was very clever. So who knows what could be done?
Right. And we just have a little bit of time left. And in the start, I became aware that at least two of you go way back. Ron and Carol, when was your first opportunity to work together?
Well, we were actually born together in the same hospital, about 2 beds apart.
Yeah.
Are
It's
you
been
guys?
a long time.
Not quite, but nearly so.
In Purdue, I think.
You want to tell us?
Were you president of ASCE? Was that right? I think you were. Was it selling the T-shirts and the underwear? I think that was my first introduction to Ron.
We need a whole nother hour to talk about the T-shirts and underwear.
And then the And then the trip to Purdue, or was that your that was
Yeah.
so much fun.
So for the members of
The
the
trip to
audience,
Chicago.
Carol and I were classmates back in the day at Purdue. We actually sat next to each other in lecture and kind of
Wow.
played off of each other. So we go way back. We're classmates.
I saw Carol do the fist pump when you said "Go Boilermakers."
Yeah.
Have any of
So
the
not
others? I know John and Ronnie probably have worked together quite a bit. Anyone else have those shared experiences?
Well, I'd say beyond just our schooling together, Carol and
Mhm.
I have worked on our two companies that work together on a whole bunch of towers in Chicago.
Numerous
We're structural
projects.
engineers,
Yeah.
and Carol's done all the connection detailing. So we
Yes.
work together frequently. So it's quite fun.
We
actually.
do. Yes, we love working with you guys.
Yeah.
Good company.
Vice versa.
Ronnie mentioned those projects, some of them that go better than others. Yeah, Ronnie, we've been on both sides of that table with you. And
Yeah.
seems to always be someone else at the table that doesn't want to cooperate. But when everybody cooperates, it goes a lot better.
Absolutely.
Well, certainly knowing each other, and a lot of us know each other from the volunteer activities that we're in. Those can help things go a lot better.
And Bo and I worked, although Bo doesn't know it, we've done a lot of jobs together, but mainly him helping me through horizontal gussets. So thank you for that, Bo.
Well, and the TC6 work, so we've been involved in discussions on TC6, and always appreciate the, of course, so we kind of always expect engineers to be smart, which of course Carol is, but the one of the main things that I appreciate about her is the practicality, being able to fit things together and know if it can be fabricated economically and things like that, and also just experiences from jobs like that. One of the issues that she brought up recently in TC6 was really important. So
Yeah, it's great that AISC processes aren't just about writing standards; they're about knowing each other.
Yeah.
See that in NSBA as well. Now, I'm sorry to say our time draws to a close here, and we'll have to wrap up our conversation. I appreciate very much all of you spending your time with us today as panelists, and all the people that dialed in to listen to the conversation. And at our first Steel Table Talk, congratulations to all of you again for the award you received. And I'm so pleased to share this virtual stage with you as a result of that. Our next Steel Table Talk is on Wednesday. I mentioned it earlier. It's at 2 p.m. Central Time, just like this one. And we'll have a group of award-winning educators. And I hope you will tune into that. For now, have a wonderful afternoon, and continue to have a happy Steel week. Thank you again to everyone.
Thank you.
Thanks.
Thanks,
All
Charlie.
right.
thanks, Charlie.
Thanks, Charlie.
Thank you very much, man. Nice to meet everybody. Be safe.